everyone. We are back with another topic of our course, which is green chemistry. And in this topic, we will learn about the 12 principles which are comprised into the green chemistry. As I already said, that green chemistry comprises of the 12 principles, and we will be dealing here with all the principles one by one. Let's see first what are these 12 principles. So these were the 12 principles of green chemistry, and we will learn each one of the principles one by one in detail. The first principle is the prevention. It's better to prevent waste in any synthesis than creating it at the very first place. The most important and the first principle is the prevention of waste. And waste produced often measures using metric E factor, which was described by Roger Sheldon. And it is the ratio of weight of the waste produced versus the weight of the product which is produced. Another index that is used is the active drug ingredient, and nowadays industries are also using these factors to minimize the waste in their byproducts. The another principle is the atom economy, which says that how many atoms are there in the reactant and how many of them are there in the product. The more the number of atoms in the product side, lesser is the wastage. Here comes the principle of atom economy. This was developed by Barry Toast. He was the first one who asked that what atoms of the reactants are incorporated into the final desired product and what atoms are wasted. Traditionally, the efficiency of any reaction was measured by calculating the percentage yield, that is by weight how much of the product is produced by weight of the reactants. But you can see here in this reaction we have seen that the percentage atom economy is being calculated, and it is the number of the atoms utilized by the number of all the reactants into 100, which gives us 50% of the atom economy. Even if our yield is 100%, only half the mass of the reactant atoms is incorporated in the desired product, which gives us that the other half are the unwanted byproducts. So we must design such methods which gives us more insight into developing this method. Here, next one is our less hazardous chemical synthesis. Like all the synthesis methods which we use should have less toxicity to human health. Less hazardous chemical synthesis means the usage of chemicals which are not very toxic to human beings as well as the environment. An example that we can take here is the usage of phosgene in synthesis of polycarbonates. Nowadays, this is not done by using phosgene, rather than triphosgene is used, which is less toxic, and its phase is also solid phase. Next one is designing safer chemicals. Of course, we should not synthesize such chemicals which are very toxic. Even if they are very much of use, we should find some alternative to the chemicals which are toxic. As you can see here, designing safer chemicals comes with minimizing toxicity while simultaneously maintaining the function and efficacy. Requires an understanding of not only of the chemistry of the chemicals but also of the principles of toxicology and environmental science. Highly reactive chemicals are quite effective, but in achieving molecular transformation, they are more likely to react with other biological elements using including the human beings and resulting in unwanted adverse effects. So we must try to minimize their usage. Wherever there is some substitute, we should try to go with the substitution. The use of auxiliary substances, for example, the solvents, separating agents, etc., which are often used in the synthesis, are usually very reactive and they are toxic in nature. So we should avoid them. We should avoid these steps in the synthesis which require these kind of solvents. Without the solvents, reactions or carrying out the syntheses are quite impossible. Around 50 to 80% of the mass in a standard batch chemical operation depends on whether water is included or not, of course. So we should try to use such alternatives which are less hazardous, like solvent-less reactions. We have a particular branch which goes into researching into usage of minimum number of solvents in steps of the reactions, and then we can use very innocuous kind of solvents like water and other polar solvents which are not at all harmful for environment. Design for energy efficiency. This is a recognized principle. At present time, it's very important because energy requirements should be recognized for the environmental and economic impacts, and they should be minimized. Synthetic methods should be conducted at ambient temperature, and as energy is a key issue in the present time, and since we have a long dependency on the fossil fuels like petroleum, coal, etc., so traditionally there was little or no consideration to spending this amount of dependency on fossil fuels, but now there are ways for which we can substitute these forms of energy. So we have to look forward, we have to find some alternative that how this can be changed, and we have to shift our dependencies on renewable sources of energies, of course. As I already discussed that renewable feedstock should be used more and more. A raw material or feedstock should be renewable rather than depleting whenever technically and economically practicable. Mankind is largely dependent on exhaustible and non-renewable sources of energy, but we have to shift our dependency on renewable sources of energy. And green chemistry proposes this principle in an attempt to solve these global problems by creating a bio-based economy which with remarkable renewable feedstocks or biomass as its raw material. So this is very important. In the past 10 years, significant advances have also been made from small scale to large scale. This includes biodiesel from plants, oils and algae, bioethanol, biobutanol. These are being also formed, and then there are cellulose, plastics, foams and thermosets formed from lignin and plant products. Even electronic materials from chicken feathers are also synthesized. So we have to look forward to develop this method so that dependency on non-renewable sources is more and renewable sources is lessened. Whenever we are synthesizing things, there we try to deprotect the functional groups. We try to block them. So this unnecessary derivatization in the synthesis should be stopped. If not needed, if there is an alternate, we should not go with them. As we saw that the production of derivatives should be minimized, and one of the best ways of doing this is by using of enzymes. They are very specific in their action, and they can often react with one side of the molecule and leave rest of the molecule alone, thus reducing the need for the protecting groups. One of the examples is enzymes. Usage of enzymes to avoid protecting groups and cleanup processes is the industrial synthesis of semi-synthetic antibiotics such as amlitecycline and amlocycline. As we can see here that beforehand the industrial synthesis of penicillin required more conditions and more solvents, etc. But now this has been replaced by a simpler method which can be carried out at room temperature, and that also without any harmful solvent. The next principle is the catalysis, and catalytic reagents, they are as very selective as they reduce the energy barrier, and they are superior to stoichiometric reagents also. So we should move our focus towards catalysis, as we have seen that catalysis is very important for industrial processes to maximize the product formation and minimize other side reactions, etc. Catalytic hydrogenations, which were widely used in petrochemical industries due to dosage of inexpensive hydrogen as redundant, is a classical example of that. Only in the last 2 decades, following the emergence of green chemistry, catalysis has been widely used in pharmaceutical industries and petrochemical industries also. The usage of homogeneous, heterogeneous, and organo catalysts is also used along with enzyme catalysis. So we should shift our focus towards the catalysis part. Then there is design for degradation. As we can see here, chemical products that should be designed so that at the end of their function they break down into innocuous degradation product and do not persist in the environment, which can be harmful for us. So if we degrade such chemicals, such molecules which are self-degrading, they are biodegradable in nature, they have very short half-lives in water, soil, or air, then the rate of polluting the environment would also be minimized like this. Then the 11th one is the real-time analysis for pollution prevention. So the analytical methodologies needs to be further developed to allow real-time in-process monitoring and control prior to the formation of hazardous substances. Real-time feedback is essential in proper functioning of the chemical processes. Feedback analysis can be performed inline, online, or at line in a chemical plant. A sub-discipline known as process analytical chemistry is also taught in many of the laboratories. Then knowing the product is done can also help prevent waste and increasing energy efficiency. So while the traditional rules of analytical chemistry also advance to achieve the chemical goals, the effective application of process analytical chemistry directly contributes to the safe and efficient operation of chemistry worldwide. Then there is safer chemistry for accident prevention. Obviously, the way we design our processes should be such that they should be hazard free. They should be chosen so such that they minimize the accident. So safety, as we can define as the control of the reorganized hazards to achieve an acceptable level of risk. We have to go with the processes. The procedure should be such that to minimize the accident occurrence, the workers, the laboratory workers, or the workers in the industries are the first in the line to get benefit from such hazard reduction. So we should have these kind of methods. We should go with them. So at last we can summarize that green chemistry is the demand of the present world. We have to go with it so as to have sustainable development. Only then. You can see here, these are the references that we use to prepare this particular topic. Thank you all for watching this particular topic, and have a good day.